Hi everyone, welcome to BHARGAV SUBS. So in today's class, we will discuss a topic regarding for example, if you project or propagate a electromagnetic wave. Okay, electromagnetic wave means it contains both electric wave and magnetic wave. Yeah, so electric wave and magnetic wave means both will travel perpendicular to each other. The wave contains both electric wave and magnetic wave. Each other are perpendicular to each other. Like they are made at an angle 90 degrees. So they propagate in all three directions: x direction, y direction, z directions. Also, it has three dimensions. So it contains both electric and magnetic field. Like if it was travels in x direction, for suppose it travels like electric wave, then magnetic wave will travel like this. Okay, like perpendicular. These are perpendicular to each other. Okay, one was travel like along horizontally, one was traveling along vertically, right? So I want to calculate the speed of the electromagnetic wave in vacuum. Okay, so I want to calculate the speed of the electromagnetic wave in vacuum. What is vacuum? Like what is meant by vacuum? Vacuum means what? There was no pressure, there is no particle, there is no gas. Correct. If perfect vacuum means there like nothing, it was nothing. And also generally we will have a atmospheric pressure is 1, but in vacuum it was almost very lower value. It was very lower value, like atmospheric pressure. It has no pressure at all. It has no particle. It has no gas. So it was vacuum. It was empty space. Nothing in there. So I want to calculate, is a electromagnetic wave propagate in vacuum or not? In air, normal air, if you take either it can propagate or not, like it can propagate. But in vacuum, what about vacuum? So if I get a speed, if it is a speed is 0, then it is not traveling. But if you got a value for the speed of the electromagnetic wave in vacuum, then you can say that it was traveling in a vacuum. So how to prove that? How to find the speed of electromagnetic wave in vacuum? So let us do that. Correct. So let us find the value of electromagnetic wave. You know, like electric field and magnetic will propagate in a perpendicular direction to each other in all three dimensional axis. Yeah. So now I want to calculate the speed of electron. Before going that, like see, what is this mu naught? What is this epsilon naught? Mu naught is the permeability. Okay. Mu naught is the permeability. What is epsilon naught? Permittivity. So permeability means what? What is the capacity of a magnetic wave can propagate in a magnetic field? Okay, its ability, or what we call like its capacity, like how much freely, correct? How much freely a magnetic wave can travel in a magnetic field. Permittivity means how much freely it will travel in electric field. Okay, electric wave will travel in electric field. Okay, yeah. How much freely I will enter into my home? Very freely, like without any obstacle. How much freely I can enter into your home? With some obstacles, like there is some restrictions. Similarly, how much freely it will enter into his own fields. Okay, that is known as permeability. Permeability for magnetic field, permittivity for electric field. What is the permeability value? 4 pi into 10 to the power of minus 7. This one 8.8 into 10 to the power of minus 12. This was the permeability value. This was the permittivity value, right? Coulomb square per Newton meter square. Yeah, these are units. Like this was like hertz per meter, like that. So there are units for each one, like permeability and permittivity. So we will discuss in problem while we calculating. We will write the units and we will calculate those. So before going that, now what I have to do this to find this. Yeah. So before going through it, I have to take 4 equations. What are the 4 equations? Belongs to the Maxwell equations. So yeah, speed of electromagnetic wave in vacuum. Okay, electromagnetic wave in vacuum. So for that I have to take 4 equations, correct? I told you. What are the 4 equations? Maxwell equations. Okay, Maxwell equations. So you can write very easily these Maxwell equations without by hearting. Okay, without any remembering, you can write very easily. So how you can write? First one, take first electric field, then magnetic field. Take first electric field, then magnetic field. Del dot E, I took electric field. Second one, del dot B, then I took magnetic field. Dot product or no? Cross product. Del cross E. Fourth one, del cross B. Simple. I wrote. Now, what are the dot products? 0. 0. What is that? What is what? Del cross E. Okay. So, this was rho minus rho B by rho T. Okay. This one minus mu naught epsilon naught rho E by rho T. Okay. What is this last? Like I can give you a name for this. Okay, I can give you a name for this. This was known as Gauss law. Gauss law of what is this? Electric field. So electrostatics. Electrostatics. What is this here? Magnetic field. So Gauss law of magnetostatics. Magnetostatics. And this one here magnetic field there, here electric field there. Okay, magnetic field there, no? Faraday's law. This was Faraday's law. This one electric field there, Ampere law. Okay, Faraday's law, Ampere's law, Gauss law of electrostatics, Gauss law of magnetostatics. Simple. These are the 4 equations. 4 equations. Okay, it was clear. I took 4 equations. Now what I will do, see, I will take 2 equations among these 4 equations, right? I will take 2 equations. What are the 2 equations? 3 and 4. 3 and 4 I will take. First I will consider the third equation from 3. What is the third equation? Faraday's law, del cross E. Del cross E is equal to minus rho B by rho T. Okay, okay. I will apply now cross product on both sides. I will apply cross product. Del cross E is equal to del cross minus rho B by rho T. Clear? I both sides applied cross product. Now I know this formula. I know like by CBA, like what is this called? CAB BCA rule. Yeah, we know that rule. Like what is that called? Del of del dot E minus del square E. Again, like after taking 4th equation, you will use this rule only. Del of del dot E is minus del square E is equal to minus rho by rho T. So I have to apply this cross product to B. So del cross B. Okay. What is del dot E here? 0. Del dot E 0. So del of into 0 minus del square E is equal to minus rho by rho T into what is del cross B? This one, this value. So minus mu naught epsilon naught rho E by rho T. I substituted, simple. I substituted like del cross B. I substituted the Ampere law in this. Now minus del square E. This was 0. Del into 0 is 0. Minus del square E is equal to minus, right? Yeah. Like it was plus, wait, it was plus. Okay, it was minus rho B by rho T. This was plus. Okay, so I substituted the plus, like mu naught epsilon naught rho E by rho T. Okay, now what I will take? these are constants, mu naught epsilon. Before only I told mu naught is the permeability, epsilon naught is the permittivity. It belongs to the electric field, it belongs to the magnetic field. I will take constants outside. So minus mu naught epsilon naught. This is the differentiation of, like, partial differentiation of, another time partial differentiation of E. Okay, so like rho by rho t of rho e by rho t, what? Rho square E by rho t square. Correct. So minus get cancelled. Finally what I got? Del square E is equal to mu naught epsilon naught rho square E by rho t square. So this is the first equation. Again I will take fourth one. I will take fourth equation. What is the fourth equation? This one. Del cross B is equal to, okay, I will take fourth from 4. What is the fourth equation? Del cross B is equal to mu naught epsilon naught rho E by rho t. Again I will apply like cross product on both sides with del cross B is equal to del cross mu naught epsilon naught rho E by rho t. Right. I know this was like del square B, sorry, del dot B minus del square B is equal to, again I have to what is it called, like I have to cross product of E, so mu naught epsilon naught rho by rho t of del cross E. Okay, I have to cross product to E, right? So del of, this was 0, del dot B is 0, so 0 minus del square B is equal to mu naught epsilon naught rho by rho t. What is del cross E? We told third equation del dot E. Okay, del dot E, rho minus rho B by rho t, minus rho B by rho t. Yeah, and I have to, like, again minus del square B is equal to mu naught epsilon naught, minus there, no, so minus mu naught epsilon naught rho square B by rho t square. So minus gets cancelled. So what I got now? Del square B is equal to mu naught epsilon naught rho square B by rho t square. This was the another equation I got. Let us consider this as 1 and this as 2. Right. Now I told you electric field and magnetic field both can be or like propagate in x direction, y direction, z direction. Okay, it was a 3-dimensional axis, correct? Like it moves in a 3 dimension. So I can write dou square B x is equal to mu naught epsilon naught dou square B x by dou t square. Dou square B y is equal to, sorry, del square B y is equal to mu naught epsilon naught dou square B y by dou t square. Del square B z is equal to mu naught epsilon naught dou square B z by dou t square. Correct. Similarly for this also, del square E x is equal to mu naught epsilon naught dou square E x by dou t square. Del square E y is equal to mu naught epsilon naught del square E y by dou t square. Del square E z is equal to mu naught epsilon naught dou square E z by dou t square. So I got 3. Here I got 3. Okay. So it was propagated in 3 axis. It also propagating in the 3 axis. Okay. So see here, like here you are getting B, here you are getting B. Same. Here you are getting E, here you are getting E. Okay. So like you can write that commonly, like both these six equations, these 3 and these 3 commonly can be written as, okay, here I can write, wait. So you understood now, like how you got, like from third equation and from fourth equation we got those equations. Okay. So commonly commonly what I can write? Yeah, so now commonly I can write like F dou square F is equal to mu naught epsilon naught, okay, dou square F by dou t square. And commonly I can substitute for F, where F is the Ex, Ey, Ez, Bx, By, Bz. Ex, Ey, Ez, Bx, By, By, anything like these three equations, right? So the this was the general equation, or it was the equation. Now I can write commonly. So this was the third equation. Dou square F is equal to mu naught epsilon naught dou square F by dou t square. Now general equation of wave. What is the general equation of wave? General equation of wave. Dou square F is equal to 1 by v square dou square F by dou t square. This was the general equation. Okay, fourth. Now I have to compare both. This was the general, by calculating all the equations I got general equation. So I got this equation. I am comparing general equation. On comparing, what are the equations I am comparing? On comparing 3 and 4, I will get 1 by v square is equal to mu naught epsilon naught. Okay, where v is the speed. Okay, v is the speed. Speed of the electromagnetic wave, right? Speed of electromagnetic wave. So v square is equal to 1 by mu naught epsilon naught. What is v then? 1 by root mu naught epsilon naught, right? You know, like mu naught values, epsilon naught values. V is equal to 1 by root over 4 pi into 10 to the power of minus 7 into epsilon naught value 8.854 into 10 to the power of minus 12. So after calculating this value, okay, in pi you have to keep like 3.14, 4 into 3.14 into 8.854. So you will get like approximately 111 or something. So like 10 power minus 7 into 10 power minus 12, which is 10 power minus 19. So 10 power minus 19, like after calculating root whole value, you will get approximately 2.99 into 10 to the power of 8 meter per second, like which was equal to 3 into 10 to the power of 8 meter per second. So we got velocity of light. It was velocity of light approximately, right? So you can finally say that electromagnetic wave can propagate through vacuum with what velocity? With speed of light. So vacuum allows electromagnetic wave to propagate through it with a speed of 3 into 10 power 8, which was equal to the speed of the light, in vacuum, right? So this was the derivation of the speed of electromagnetic wave in vacuum. Yeah, hope you understood. Thank you.